myself is I'm working with Osram now a bit more than 4 years. I'm heading here in Munich, or more precise in Garching, engineering team working on connected IoT products. In the past, we also had some joint engagements together with Concept Reply, and before that, I was around 2 years with Samsung Electronics working on IoT. And my background is in computer science, and as a side note, like my career started as a Java programmer already quite a while ago, but in the recent years, more and more towards like embedded and connected technology for IoT. And yeah, for today, I don't want to make it a advertisement session for Osram. I just want to give you a short overview what Osram is or what the company is about, and then discuss more in a general sense what are like use cases for smart lighting and IoT. A rough overview of our products, but more also a bit what kind of technologies we are using, and finally, I think this could be probably interesting for a bit more people, like a demo of a recently launched IoT controller that has also some external APIs that can be accessed. So that would be roughly the idea for today, and I'm looking forward to a good exchange with you guys.
Turn the microphone off and come back. Markus, can you hear me from here, or was it too weird?
I can hear you now. Now Excellent. It's very good.
Yeah, okay, so I can sit back here and play. Yeah, great. So yeah, I know it's one of these weird things where you do half remote, half real, and I never really know how to kind of manage the two together. Actually, I think if anyone actually has any questions, it should work. So it should be, if you could speak here, Markus can hear you. If you have any questions already. If not, then I would say let's have, say, 10 minutes while I at least get some food. Yeah, because we start at 7 officially. And yeah, if that works for you guys, because a few guys going to start at 7. We'll go arrive at the call at 7, and if that's okay for you, Markus, I hope it's not too weird. Just be watching us mooch around and talk. I'll leave the microphone on, just so people know that, so maybe don't swear too much. And yeah, that hopefully will merge the two worlds together slowly. But yeah, I know it's very strange to do the two calls at the same time. It's really, really odd. Okay. So in that case, I'm going to get a beer and I'm going to eat something, because I haven't had something for a long time. And yeah, if anyone wants to talk in the call or talk here, feel free. I'm hoping the two worlds will merge. But I always have this thing that people see a Teams call with all the names, all the faces, and the guys just get very quiet. And yeah, that's just how it is. I don't know if I'm going to try and fix this YouTube stream, but apparently it doesn't want to accept the equipment here. So I'm just going to keep it as Teams call. I'll just upload it later. I'll put a comment. But if you know anyone that's actually viewing online and wants to view, just ask them to join a Teams call. Unfortunately, none of this stuff I'm actually really officially allowed to use. So I always just log in and I hope for the best. And YouTube can't find this equipment, unfortunately. So, Teams call works though. That's great. Okay, I'm gonna eat. So if someone wants to join me and talk, then feel free. Just be aware that the microphone is turned on, so the guys, I don't know.
Enjoy.
Yeah. Just if you have any controversial opinions about things, just maybe keep them to yourself. That's actually more beer in the fridge. Yeah, it's on there. Yeah, what's really weird is actually if you broadcast the screen. No. Yeah. Look what is there. Look what is there. Yeah. Changing. Yeah. It's a little bit. Yeah, it's flipped. That's why it was. Yeah, it's really confusing because when I was going back, yeah, and it's going in the. It's very strange. Yeah. It wasn't this one, but the different one. There's two cameras. There's two cameras. The camera. No, there is more cameras. If you want me to, these presets. And these the two cameras. There's this camera here, and then there's this camera here. So you can switch. Yeah. However, they're called different things. So, so this red one here, this is what's being broadcast. So you can actually you switch between the two. You can switch, yeah. So yeah. So that's kind of cool. Interesting, yeah. Show the people. Yeah, definitely. This mounts the webcam, but for some reason the browser doesn't mount. They see this as your webcam, and you can select what you want to see. So yeah. You can even select the screen to right. Suggest your screen. Yeah. Yeah, me too. I was told 15. That's
I'm working like every day as a big data consultant. There are people who speak about it.
Right, you're the one.
I'm working on it. We have been working with for example, collaboration of some kind of because they may query or basically you can start using just queries.
Okay. Guys, Markus, you still there?
Yeah, still here.
Markus, can you talk, please? Sorry.
Yes, yeah, I can hear you. So should I go ahead?
Okay.
Can you hear me?
Yeah, I can hear you. Yeah. I just need to. I'm gonna mute my microphones.
Okay.
And then. Okay. Cool. Yeah. Okay. So.
Should I go ahead, Alistair, or?
Yeah, that's okay.
So excuse me, Markus. I muted the microphone so I could test something. Yeah. So let's start, Markus. Can you just talk?
Okay, good. Then I go ahead. Yes. So I did already my self-introduction. For those who joined a bit later, thanks a lot for your time, and also thanks a lot for the opportunity to talk in this round today. What I would like to present you today is like a short overview of Osram as a company, and not only an advertisement of our products, but more like what are the currently technology trends in smart lighting and IoT, what use cases are driving us, and a short intro of a recently announced or launched IoT product from Osram with open APIs that might be of interest for you or for developer community in general. Okay, then let's get started. I think there's still a bit an echo, so it would be great if you can mute your mic. And in case of a question, then please go ahead and use the raise hand function of Teams, and feel free to interrupt or to ask. So first of all, I want to ask you, who of you already knows Osram and what we are doing? Also, maybe what our name, how our name is originated. Maybe Alistair, in case nobody else wants to answer. Do you know Osram or what products?
I know Osram, yeah. But yeah, I live in Augsburg, so.
Okay, okay, good, yeah. So Osram is a lighting company. We have like more than 100 years background in lighting, and actually the name itself is an artificial creation of two elements that are used to initially create this metal in the light bulbs. It's osmium and wolfram, and that's how the name Osram was born, like more than 100 years ago. But these days we are not really in light bulbs anymore. So you can see here a range of products that we are selling or producing, and it's a huge range from LED products towards automotive products. You might find Osram products in your smartphones, in your watches, for sensing technology, everything with structured light. And of course, everything that goes into light management systems, IoT, vertical farming. So it's a quite huge variety of products. And overall, the company is quite big sized. 23,000 employees worldwide, and the general markets or products that we have are currently like in the opto-semiconductors area, like LEDs and sensors. And in the automotive area, you might still face as a consumer our products in supermarkets, the headlamps of cars. This is still something that we directly sell for the consumer market. And finally, the digital segment, where also all our connected products and portfolios are inside. And Osram was taken over by an Austrian company this year, by AMS, and this is completed this year, and you might have seen some news about that. So what is Osram doing in the IoT market? For us, coming more from the kind of traditional lighting market, it's kind of a evolution towards digital solutions. So for light management systems, typically the main focus is to provide you a convenient light environment, to have a very efficient lighting, to save energy. So that's basically everything that's connected lighting or the standard lighting light management functionalities. And with our products, we also want to go beyond that and utilize the infrastructure that we have for more use cases and for more services. And lighting is in principle a very good, or has a lot of opportunities. Just if you look now in your office room or in your event meeting room, if you look on the ceiling, you have luminaires everywhere, you have power everywhere, and that's a perfect starting point to utilize this infrastructure for other use cases. And IoT and lighting is quite big. There can be multiple verticals you can go into. And for Osram, the main focus is on commercial buildings, in industrial environments, factories or plants, and entertainment or architectural outdoor lighting. So this is the main focus. So Osram is not really looking into smart homes. So all these consumer-related topics are not really in our focus. And then, of course, the question is, what are we doing with IoT, or why are we connecting luminaires? Why are we connecting sensors there? It's not only like a self-purpose because the technology is cool. You want to address some customer needs or some problems. And coming from a traditional lighting infrastructure, one very obvious IoT use case is predictive maintenance. So we try to address here to give the customer insights in his light installation, how the light sources are working, is the end of life of the luminaire reached, or how long it will take until he can expect the degradation of the luminaire. Also, use cases here like to get some direct error feedback from the installation in case there's over temperature or like over voltage in some of the components of the luminaire that might create a problem, or of the lighting installation. So this is one of the more straightforward use cases we are looking into. Something that's now gaining popularity is so-called human-centric lighting. So in this case, you equip your lighting installation with different light colors that can help to make your work environment more comfortable. So it's helping to adjusting the body to different environments and to activate the people and to have like more comfort and more productivity. So these are more like the use cases that directly circle around the lighting topic. And going beyond that, what you can do is typically like lighting installation comes with sensors and with presence detection, movement detection. So you can use this to optimize, on the one side, your energy consumption, because you only want to have the light at full power if there are people around. So if you utilize presence sensors for this, you can already make a lot of energy savings. And you can also get more insights in how your building is used and how it's utilized. And you can, based on this information, do also like a space optimization. And this use case is especially now interesting in the context of Corona protection measures, So what we are doing is we are also using here like advanced sensors that can count people in areas, that can see if like distances are not kept. So you can go beyond the traditional lighting application and utilize this infrastructure for more use cases. And considering that you typically have in a IoT lighting installation like a wireless mesh network for connecting all the luminaires, you can also utilize this and, for example, in the industrial environments, use this infrastructure for facility monitoring. So we have here systems that allow you to monitor the environment, for example, for temperature and humidity, which is interesting if you have something in logistics or storing goods that need a certain environment. You can also use, for example, CO2 sensors. This is also on the one side a good indication in an office building if you need to get fresh air into the room, because people start to get tired if the CO2 levels are too high. And also now in the Corona context, the CO2 value is helping to give insights if there is a high threat that the air is potentially not safe and needs a kind of refresh. And also an interesting use case in this context is asset tracking. So if you equip the light infrastructure with so-called sniffing devices, or you utilize the existing wireless network for this, you can track how the goods flow through the production. And these are, in a nutshell, I would say the use cases that we are looking in and that we are trying to solve and to provide a product or a solution for our customers. On these use cases already, any questions or comments?
Does anyone have anything? Any comments, questions? I think everyone's quite happy so far.
Okay.
Good job, apparently.
Good. Then I go ahead.
Yeah, definitely.
So about the technologies, I don't want to give you too much specs on these technologies. I think, or I guess that most of you are aware at least of like wireless technologies like Zigbee or Bluetooth. So in general, in the commercial smart lighting domain, you have on the one side wired communication and on the other side wireless communication. So especially in the European market or German market, what is still like one of the biggest technologies is wired communication based on DALI. So you can see here like basically a DALI cable, and it's like a power cable with two additional wires that are used for communicating to the luminaire. And this is a quite strong technology because you only need an electrician. Like you anyway need an electrician to install the lighting, and you have then at the same time also the network installed. And on the other side, for if you want to go to IoT use cases where you need more bandwidth, you have to go wireless, because with this DALI technology, it has only 1 kilobit a data transmission rate, and that's good enough to control luminaires, to control lighting groups, to get maybe a simple status update from them, but it's definitely not sufficient to have like a lot of sensor data transmitted or to transfer firmware updates if you want to update your devices. So it's limiting if you want to go into IoT use cases. And with the other wireless technologies, you definitely have more bandwidth, more data rate that you can utilize. And in principle, you have also the benefit of combining your lighting infrastructure with battery operated sensors. And this is especially interesting if you want to place the sensor like into some certain areas of the shop floor where you don't would reach otherwise. And you have here multiple options like Zigbee or Bluetooth Mesh or Thread. And if you would ask me what's the best technology, it's basically all of them or a combination of them. So I just took here like a market overview from the Let's Inside magazine, and you can see here that, for example, the market is basically split these days between Zigbee, Bluetooth, and DALI, and that's basically also what Osram is providing here. So Osram is not like going in on one technology. We are just following here what the market demands, and currently, the market is split mainly in these technologies. And any comments or questions on that?
Yeah, because sorry to interrupt you. What's the fun a good time? But I failed. Vincent actually has a question in the chat. Can you see the chat, or shall I read it out?
Please read it out. I'm in the presentation mode, so I cannot see it.
Okay. So what about KNX as a protocol?
KNX is strong in the home and building automation environment, and in the context of lighting, it's also strong to integrate then luminaires into smart buildings. And for KNX is also, I would say, like everything that has a input device, like a push button or like a room touch element. So they usually also have KNX. So yeah, I don't have it in this overview because you hardly find, if I go on the next slide, drivers that are directly based on KNX. I mean, there are some, but I think the biggest market share is basically DALI for this LED drivers.
Are you happy, Vincent, with that answer?
Yeah, that's fine. Thank you. I was just curious or surprised not to find it on the slide.
Okay, excellent.
Yeah,
okay.
So I took it from this magazine. So it's like public knowledge and mainly focusing on the lighting domain. And what kind of devices are we looking into from Osram? So Osram itself is a big provider of components. So we are doing this LEDs that go into light engines, into the lamp or the light module, and powered by an LED driver. So the LED driver is transforming the power from the mains to the current or voltage or power that the luminaire needs. So on the one side, connectivity is interesting here, and on the other side, let me use a pointer. We are also doing controls, and here it means like that you have like, for example, a sensor, a presence sensor that can detect if people move around. This can also be a sensor with for light intensity that is able to talk to this LED driver. And the LED driver itself is typically wired through DALI, and you use then this DALI line to directly talk from this sensor module. And IoT devices in our context are typically microcontroller-based devices with only a few megahertz or kilobytes. And since this is a big volume business and every cent counts on these devices, it's usually very constrained or optimized to have here like only as much as resources that you need, and to limit this as much as possible. And in the context of the IoT use cases, what information can you get from these devices? So recently, like the capability is added to get real-time power metering and also diagnostics information. So you can help to solve the use case for energy efficiency, for energy monitoring, and also for predictive maintenance. And these LED drivers are also now equipped with a capability to power external sensor modules. So the idea is here that you provide the luminaire manufacturer a way to integrate additional sensors and to utilize the power infrastructure that you get from the LED driver. And the sensor module is then, for example, providing you the wireless connectivity. This could be, for example, Zigbee-based. So this product that I'm showing here is a Zigbee-based product that we have in the portfolio. And this is in principle also possible to directly connect with, for example, Thread as a technology, to have really here an IP to the sensor communication and directly connect to the cloud. But here there's, I would say that there's not yet a market for this. So the technology is in principle there. We also demoed here like a prototype or innovation concept at the last Thread member meeting, where we showed how such a sensor module can directly talk IP to a cloud backend to report energy readings, to give insights into potential maintenance information, also to have a direct control. So in principle, I would say that the technology is ready, the technology is there, but the market is not yet established, or the market is not there. And considering all these technologies, what's kind of emerging, or as in system architecture on that side, is that you have typically a luminaire. Like this, the luminaire is basically the whole light fixture with the light engine. You have an LED driver, and what we see in Europe is still that there's a lot of DALI communication happening. And then you go to a sensor module that is basically doing the wireless or the wireless mesh connectivity. And within Osram, we have here some systems in the portfolio where you then have either a Zigbee-based communication or a Bluetooth mesh-based communication. And just to give you here an insight into one of our systems, so Osram has here multiple systems. It's, for example, the digital lumen Sidework systems. What we do here is we focus mainly on industrial environments. We provide here energy efficient LED luminaires, and you can see here the sensor for activity detection is integrated, and this system is providing you like a wireless mesh based on Zigbee in an industrial environment, in a warehouse. So I have also here like a real device, how this can look like. And we utilize now this wireless mesh network also for other use cases. For example, you have battery operated sensors that can be placed anywhere in the factory. We have power meters that can be placed to meter the energy readings of any machinery, also to detect the status of any machinery if there is maybe a problem that you can detect through vibration. So we try here really to utilize the light infrastructure as a basic infrastructure for more IoT use cases. And also connect through like a gateway device like this to the backend, and provide here like insights into a cloud-based dashboard that can help you, for example, to track goods and people and to see how the value stream of your goods are, and to optimize your spaces. And the thing here with this is this is basically Osram has multiple businesses. So we are selling the components itself in a big volume. And this one is basically a system that we sell directly to the customer, and it's like a one-stop solution. So it's a closed system, and you get it from the luminaire to the cloud backend. Everything is here included. Any questions so far on that topic?
Any questions? They're all very happy here. I think
okay.
they're absorbing it. It's nice to see.
Yeah. If I hope it's not too much, but yeah, that I'm going now towards like a more like demo part of the talk. So and that's what I thought could be interesting for the group here today. Like what I also want to show is like we recently started like this product. It's like was released in September. We call it DALI Pro 2 IoT. And it's the next generation of a product that's already in the market for more than 10 years in Osram. And it received an upgrade that provided it now more IoT capabilities. So on the one side, it's DALI certified, so you can use it to connect to new DALI 2 devices. And in contrast to the previous system, it has now also the capability to have a USB Wi-Fi dongle, and it runs with a browser-based web user interface that allows to do self-commissioning. And it can also connect to cloud backends and has state-of-the-art IoT security integrated. So it's quite flexible or versatile product that is targeting for the IoT and for IoT use cases. And the main upgrade what we provided to this product is that we put a Raspberry Pi compute module inside this lighting controller. We also added an embedded Linux, in this case Ubuntu Core, and this gives now the opportunity to have a lot of additional processing power and capabilities, like what you would know from a Raspberry Pi inside this lighting controller. And with the use of Ubuntu Core, you also have the capabilities to run quite versatile software packages or software on these devices and on this device. And here we are also, like for the next release, working on open API access, so that it's possible from within the local network retrieve information about your active lighting project, read out information from the luminaires, subscribe to updates on the power readings, and also to actuation on the devices and a change on the project configuration and commissioning. And the idea is to have these open APIs directly locally on the device, and also provide a capability to upload so-called custom snaps. So if you are familiar with Ubuntu, one way of shipping software packages is to use so-called snaps, and this is also possible to do on this device. So it's now a very flexible Linux-based software system where you can run a lot of interesting stuff and add additional features and services on top of it. And now I would also like to give you a short demo of how this looks like. Initially, I planned to bring a demo suit case to the meetup, but unfortunately with the Corona situation, we have to do it remotely. So we have here like a mobile setup, and what you can see here is in principle like a small office in a suitcase, and it has on the one side a top floor and a bottom floor with in total something like 22 luminaires integrated. And from a light management system point of view, it has exactly the same devices in the suitcase that you would have like in a real setup. So it's like 22 of these LED drivers that are just controlling this small demo LEDs. So one nice feature of this IoT controller is that it comes with a USB dongle that can create a Wi-Fi access point. And this means that if you install this on in the installation, you can activate this Wi-Fi and directly connect to the this DALI controller. And that's especially interesting if you consider like a new building is built. Usually you don't have the IT infrastructure yet there. There's no IT administrator that you can ask for setting up a network. So here we provide a way of flexible self-serviced network capabilities. So installer can connect to this device and create a project, or first a user, and then you can use this web user interface to set up a project. You can start and search for your devices, and you have a simple drag and drop way of configuring configuring your environment. So you can put in here, for example, a meeting room, and then you can add sensors and group devices. So it's, I would say, just a normal state-of-the-art web user interface, which is probably for you guys not that much new, but at least for Osram and the lighting market, it was quite it's a quite nice move forward in state-of-the-art technology. So beside this web user interface, you have also a cloud interface, and here I'm directly connected to one of our real installations. So this is like a warehouse, and for this service and application, we also got good support from Concept Reply. And you can see here, for example, like how in this warehouse section, the energy readings of your light installations differ on like working days and non-working days. You can check your system health and your system status, like how many devices are online, what's your current power consumption, and also on an individual device level, like what's the total lifetime of the luminaire or the expected lifetime, and how much lifetime is already consumed. That gives you an indication when you have to expect that degradation happens of your lighting installation and when you should exchange it. You get also insights into the current driver temperature and if there are any problems that you have to consider. So that's basically it. That was a short glimpse and quick overview of what you're doing here in Osram. And yeah, if you have interest on this product, so if you want to exchange on technologies, feel free to reach out to me. Unfortunately, today in this virtual setup, it's not so easy, but you can reach me with my email address, or I'm hoping to join the next IoT meetup in person, and then it's also an opportunity to exchange here. Yeah, thanks for your attention, and if there are any questions, please go ahead.
Yeah, so before I start the questions, Markus, thank you very much for your time. And I think most of us here seem to have got something from it. There are 2 questions in the chat, but also a few questions here. I'll start with the chat, and I'll come to the guys in the room, if that's okay, Markus.
Yep.
So, first question. Can I incorporate this solution into existing Osram LED lights?
Which solution, the DALI Pro IoT, or?
Yeah, I guess that's what he meant. Is so this solution that you were presenting, could I use it with, say, a light I bought a year ago, or is it something special?
Yeah, I mean, that's the thing, that you can use it for anything that's running with a DALI LED driver. And this is typically commercial buildings or industrial environments. So Osram itself is not producing any luminaires anymore. So we are providing luminaire manufacturers this kind of drivers, and they are integrating it. So it's not the lamps that you get for the consumer market with the Osram brand on it. It's not anymore DALI, or it's not like how to say. It's not anymore Osram, and it's not like DALI controlled. It's more for the commercial buildings. Did I answer the question, or?
I think it might. I won't ask just because I have so many questions and I want to get through them. But I might just say that if anyone has further questions, put in the chat. I think Markus will reply directly. That's fair. Just to sort of go with things in time that Max has a good chance as well. So the one from Vincent, actually, how do you provision device, manually or automatically?
Like you have to, like, the search for the device is done automatically, but the provisioning is usually like also to identify where the device is in the room. And at least with DALI, this is currently a manual process. So you have to blink the device and you see, okay, now this is this device, and then you place it into a group. And this process is still highly manual, I would say.
Okay. Next question, which actually is quite a nice one. How many of your users actually integrate your IoT devices into a home automation system? So like IFTTT, OpenHub, or just use that, and not just use an app like Alexa or an app in Alexa, something like that.
Yeah, so that's the thing, like with smart home and smart home automation, is Osram is completely out of that market since 4 years, and all the consumer or smart home products, this is now under the brand LEDVANCE. And I can just say here that LEDVANCE is highly integrating with existing ecosystems. So they are working with Alexa, they are working with HomeKit, so they try to be compatible with these systems.
Okay. Sounds fair enough. And next question, the last one put in the chat for now is, do you consider Bluetooth low energy mesh as a stable technology?
Yes, we also have a system out there. It's called HubSense, and you can also find information on our website on it. And I think with the latest BLE standardization, it's getting even more mature. And what we are using here is like the stacks from external companies, for example, Silver, who have quite an experience and usually like sometimes also have proprietary modifications to make the technology really stable.
Okay, that sounds good. So I got some questions in the room. I have to say it's quite a lot of people. There's quite a few people in the room actually. They're obviously generating some interest. So I'm going to test something. I'm going to try that someone could talk in the room. You can't hear Markus say. Okay, let's try. I hope it works. So please, sir.
One question, Markus. You plan to integrate video data. I saw a surveillance camera. One of the first slides. You transport video data.
So I understand the question is if we integrate like cameras or visual data, or have the plan for it. So I think we had some innovation projects on the topic, mainly to count people and their activity. The challenge you have here is on the one side the user acceptance regarding privacy. So that's the one issue I would see there, and the other one is the bandwidth. So if you try to do something with cameras or computer vision, you have to probably embed all this processing at the device, because like streaming video data with like a mesh network with some 100 kilobytes of bandwidth is also not a good idea, or would probably not work well. And what we are doing is more like using infrared grid sensors. So it's more like a heat detection in an area where you have like maybe a resolution of 80 by 80 pixels or something like this, or 8 by 8 pixels. And we try to utilize this kind of heat information to, for example, detect people in an area or how close they're standing to each other.
Satisfied?
Right.
Yeah. Any other questions in the room? You might speak loudly, but we'll try. Go on.
What kind of cloud backend infrastructure are you using? Is it all private on-prem, or are you using cloud provider?
We are using like not on-prem. We also move to various cloud providers, and depending on the region we operate, it's either Microsoft Azure or AWS.
But then you're just to follow up. Then you're using your own protocols and not using any of the native services.
I think like we have to differentiate here two things. The one is like the component business of Osram. There we try to just follow basically what the market needs. So like if you have a big market for CP-based products or DALI-based products, we follow the protocols and standard there. But if we consider then, for example, a closed solution, like where we provide everything from the luminaire to the cloud backend, then we also sometimes use just proprietary approaches, because we anyway try to be the one-stop solution for the customer, and then you might be faster than to follow like an defined standard.
Makes sense. Thanks.
Okay, I might be mean and say that would be the last question for now, just to give Max a good chance. If you have any questions offline, I think you can just join and just write in the chat. I'm sure Markus would reply. If not, I can forward questions as well. That's fine. So hopefully Max is still in the call, and Max is still prepared.
I'm still there. Yeah.
You're still there. Excellent. Would you like to start maybe and share your screen? And I hope it works just as well.
Yes, happy to do that. Yeah, welcome from my side. Thanks first of all for organizing this event. Thanks Alistair, and thanks Concept in general for organizing this. Happy to be here. Try to share my screen. 1 second.
Yeah, it seems it's very well hidden.
Yeah. Actually, I can only share PowerPoints?
I think it's okay. I gotta think out loud now.
Awesome.
Präsentieren wieder, yeah. Should be fine. Should be fine, yeah. Can you find the button, or is it?
Yeah, I find a button, but it's just
share the desktop.
Doesn't.
Can you share the desktop? There's like there's a picture with like an arrow going into the screen.
Yeah, I know, but it doesn't give me the option for some reason. But let me check. I can only select PowerPoint.
I don't know.
Okay.
But are you on iOS by any chance, or macOS?
macOS.
You might give permissions to Teams.
No, I'm using Teams all the time, but I'm uploading my PowerPoint. I think then it might work for some reason.
Yeah, you would, yes, yeah.
All right.
I think it'll come. It's coming. It's coming.
Something is coming, yeah.
Yeah, sorry about that. Maybe because of trust between.
Yeah, no, I mean, no worries. I mean, if it works like that, I hope the animations are not entirely broken now, but let's see. Okay, yeah, well, welcome again from my side. I'm very happy to be here. I'm Max. I'm one of the co-founders of the company, which is called Actix. We are a Munich-based startup working on digitizing factories. And I'm very happy to talk a little bit more about what kind of experience we have made in the last years in digitizing factories. We are in the market since a little bit more than 4 years, and we are 25 people. Here you can find my contact details. Very happy to connect. Just shoot me an email or try to find me on LinkedIn and hit me up, and I'm happy to connect afterwards. Okay, so what do we do, and why do we exist? So in general, we're very fascinated by factories. I mean, everything which everybody sits on and everything uses is sort of built by a factory. But there's a pretty huge misconceptions usually how factories work. Everybody, at least most of the people we talk to, if we talk about factories, people think about this picture. Very much a lot of automation, a lot of robots, very clean, a lot of software is used. But if you walk into 99% of the factories in the world, the factories look actually like that. It's very dirty. It's very, very, very analog. Very much human experience is needed. A lot of paper you can find in the factory. One of the reasons we think why that is not a technology problem. There's technologies, and we are one of the technologies which make it a lot easier to digitize factories, is that people are always, at least in our opinion, overcomplicating when they think about digitization. Especially since the last years, there's a huge buzz around digitization of factory processes and factories in general, and there's Industry 4.0 and all of these things. You have machine learning and AI, and now you have blockchain and all these sort of things. And if you talk with the people in the factory, a plant manager or a production manager, they have this picture in mind. They have processes, they have machines, they have robots, they have material, and it's really difficult usually for these guys to bring everything together. And what are these buzzwords? What do they mean for me? Because in the end, their job is to deliver the right product in the right quality in the right time. And we think that in order to successfully digitize a factory, you need basically two things. First thing is you need to have a step-by-step approach, because nobody can really tell you how factories will work in 10 years. Or even 5 years probably. And our experience is that once people start to have digital solutions, there's a lot of new ideas and new concepts, and everything that you basically defined in your 5-year plan becomes obsolete once you have a digital solution in your factory. And then you need, and this is mainly what is new now, is that you need a flexible IT system that allows you to grow with the requirements, and allow you basically to go towards the future. And what we always tell people is that if you want to digitize something, if you have a plant manager or a factory manager, you should very clearly focus on operational KPIs, because this, in the end, the guys who pay you the money to build the solution are thinking about how can you improve their the uptime of the machines. How can you increase the utilization of your machines, the throughput, reduce the lead times, and improve the time until a machine is repaired. And then focus very much on a specific problem in one part of your factory, and then iteratively start and scale and grow out your solution. Yeah, go to several machines, include workers, include other things that are running around in the factory. And what we see is there's basically usually an evolution, and it can be categorized by simplified in two ways. First thing, and this is usually one of the first steps most factories are doing, and most factories are currently doing this at the moment, is building transparency and collecting data for human-based decision making. So basically connecting your machines, getting machine data, getting data from your workers, and then building dashboards, building analytics, and basically provide data to humans to make decisions on when is the best time to maintain your machine, what is the best time to set up your, what is the best way to set up your machines, and these sort of things. And obviously, this is not where it stops. This is just the first step. And the second step is, and this is even more exciting, in my opinion, this is one of the primary things that we are working on, is basically making it possible to control processes in your factory. Instead of the human deciding when to maintain a machine, you have now an algorithm which is automatically deciding when to maintain the machine, but also already initiating everything that is needed to do that. Yeah, inform the right worker with the right skills, or inform the people in the logistics in the warehouse to set up or to get the tools ready, get the spare parts ready, the guy on a forklift driver to pick up the tools from the warehouse, bringing to the machine. So everything, basically all the processes should be more and more software defined, software controlled. In the end, with the benefit for the factory to become a lot more flexible and efficient, and be able to change your process a lot easier. And at times like Corona, we kind of realize that factories are not working as well as they should probably. Even a country like Germany, who's building one of the most, or probably the most complex machines there are in the market, have a very hard time to produce a very simple product, which is a facial mask, because the processes are not very flexible today in factories. So what is Actix doing? And I give you a few more examples of what digital solutions mean more concretely. But basically, the entire thing that Actix is doing, we are building the basis to very quickly and easily digitize processes in the factory. And we are offering a programming framework and a programming platform to do this very effectively, to make the people who are building these solutions very productive. And fundamentally, what differentiates us from many other companies is that we are rethinking how IT should be built for factories. So we go away from a centralized architecture, which is the most classical architecture, where you have your centralized servers, where you have your data, your logic, and everything, which is, by the way, very suitable for many applications, especially analytics and these sort of things. But which has the downside that you always rely on these centralized components. And this is, especially if you think about a factory, very, very dangerous. So if the software, which basically helps the worker to set up the machine or defines which material should be delivered to the machine, is not working anymore, then the process comes to a standstill, which in the end means that the factory can't produce products, and this is very, very expensive, of course. And we believe that fundamentally, for replacing paper, which is the predominant means of communication in the factory today, 99% of the factories in the world, and you have to have, and you want to replace it by paper by software, the software needs to be as reliable basically as the paper itself. And we think that a decentralized architecture is much better suited to basically achieve this. And in our system, on our platform, you don't need any centralized components at all. There's no centralized servers, there's no centralized message brokers. You just have the infrastructure with which you digitize your factory. And even if one component breaks, it doesn't matter, because the rest of the system is still running. So, and we always compare it to a machine. So on the left side, you have a machine if one part breaks, the entire machine comes to a standstill. And on the right, you have a machine which is basically designed with the idea and the understanding that components can break all the time, but you still have a machine which continues to run. And so what we have built then on top of it is an application platform which allows people who want to digitize processes to very easily build applications to do that. And how this works more concretely is that you have the devices with which you digitize and interface with your machines and workers, your tablets, your scanners, your gateways, your industrial computers, where you run your operating system of the device, Android, Windows, or Linux, for example. And then you can take our platform, which is called ActiveOS, which is basically a program, a piece of software, which you install locally on the computer itself. And then what ActiveOS is doing is it provides the connectivity and the data synchronization across all the devices. So all devices where you have installed ActiveOS are recognized automatically in the local network. The data is automatically synchronized between the devices and it's automatically persisted on the device. So it's sort of a distributed database and a message broker. Just that you don't have to do anything as a developer, and the thing you can focus on is building applications on top of the infrastructure. So applications to extract data from a PLC, an application to assist a worker on a mobile device, an application for a machine to analyze sensor data, maybe to detect quality problems. So many, many different things. And you can build it in a very modular way, start very small and step by step extend the system with additional apps and devices. And the huge benefit of the system is, of course, reliability, because you don't have any centralized components you rely on, but it's the flexibility of the system is extremely high. So you don't have any IT overhead at all. You don't have any of these centralized servers. You just have the infrastructure you need to run your apps, and you use the infrastructure that you already have in the factory. And one thing which is important, so the cloud is, I think, a very, very useful and powerful technology. It's not the technology that, in our opinion, should be used to control a process in the factory, but it's you can use the cloud to basically send data to the cloud, analyze the data, make predictions, whatever, and send information back. But the factory in itself should be able to run without the connectivity to the internet. And apart from the fundamental platform ActiveOS, we support the programmer and the developer with tooling to program applications very, very effectively and efficiently, and also tooling to install and monitor and deploy applications in the factory on the edge devices themselves. So for us, the most important thing is to make the programmer, the developer, as productive as possible, and eliminate all the things, the overhead, the infrastructure setup that are usually needed, and eliminate that and let the programmer focus on building the value-creating applications for the factory. And so the way we work is that we offer this platform to anybody basically who wants to build something. Anybody who's a developer and can program can use our platform. It's available online. You can just download it and get started and build solutions for factories. And we are predominantly, the developers are system integrators and IT service provider. Could also be the IT department of a factory itself. So different basically teams and functions who can use our platform. And the main advantage in the end, what we do is our framework, our platform reduces the effort for building these solutions which need to run reliably in the factory. Maybe one comment, because I think a lot of people here in the audience are familiar with IoT and IoT technologies and use especially the cloud. So what we see ourselves as a very complementary technology to traditional IoT platforms. So the IoT platforms on the left fundamentally always have a server, sometimes on premise, often in the cloud, where you basically centralize the data to make predictions, to make analytics, to make sense of the data and create insights. You have the edge for pre-processing, for maybe also taking some decisions already on the edge, but often just for filtering and pre-filtering information that you not send everything in the cloud. And this is very useful and very powerful, especially for optimizing things and predicting behaviors. In our world, that's the right one, we are more about controlling and automating a process. So and you can see this below, the decision frequencies usually a lot faster and a lot more frequent than in the IoT domain. So the lowest level that we automate is machines talk to machines, like a robot talking with a machine and being informed that now you can pick up a material and place it on a conveyor belt, for example. And these sort of things happen in milliseconds. And then you have more or less critical or time-sensitive decisions like when to set up a machine, how to set up a machine, and control these processes, material flows, and these sort of things. But in principle, all of the decisions are much more frequent and need to be a lot more reliable than the IoT use cases. In the IoT world, often if you don't have the connectivity for like a minute or something like that, it doesn't really matter. In the world of process automation, if you don't have connectivity and your system doesn't work for a minute, could mean that you lose 1,000 of several thousands of euros because you can't produce your product. And what's very important, this is not a research project. It's a very innovative approach of building solutions for the factories. But we have quite a few of partners who are already programming on the platform. And we have factories who are running on Actix in Europe. We also have installation already in Northern America and in Southern America. And anybody who's interested, of course, in the platform, please approach me. I'm very happy to talk about that. Okay, so much to the technology side. Let's look at maybe some examples of what you can do with the platform, what we and other people have built on our platform. The first one, the case one, I brought with me is a case where it's if you remember the slide I showed about the transparency, it's about building transparency on a production process. And this is a glass factory which is producing container glasses, so like pharmaceutical glasses. There are also spirit glasses. The factory is also producing the Heineken bottles, and it's a very automated process, and all the material flow is already automated with conveyor belts and these sort of things. It's a very large production line, and the person or the human is still very important for setting up the machine and maintaining the process. And it's very difficult for the human, if he stands at the glass forming machine, which is this machine, to basically know what is the current status of the process. Are we doing good? Are we doing bad? What do I need to react basically to make my process better? And what we have built is a solution where you connect to different machines from different vendors, from the batch house to collect the recipe information, to integrate with the oven, to extract information on temperature and other information, the glass forming machines, the quality inspection machines, and then basically making this data available on the shop floor, and also like for historical analysis, but on the shop floor for the operator to understand better what is basically the status of the process. And what was very interesting, the biggest effect for the factory was for the worker to understand when he should stop a section of a machine and put grease on it. So what you need to do in this glass forming machines, you have usually 10 to 15 sections where you have the melt coming in on top. And after like 20 to 40 minutes, you have to stop it and put grease on the form. If you don't do it on time, then some of the glass breaks. If you do it too early, then you have also scrap because the glass is basically full of grease and you have to discard the first couple of pieces. And the human is not a robot, right? Like he doesn't do it like really exactly on time every 30 minutes. So what happened is that sometimes the people did it like only every 1.5 hours. Sometimes they did it every 20 or 15 minutes. And now we have this very simple application. They just see it on the screen. When was the last time that you did it? And you basically are sort of guided when you should next grease the forms. And this was a very simple thing, but in the end, it improved the quality. It's also interesting, just by 0.5%, which doesn't sound a lot, but it saves the factory over 350,000 euros per year because they produce a couple of billion glass bottles. And if 0.5% of that is also already quite a lot of money. So that's an example. I think everybody can imagine how a dashboard would like. This is the time, basically the last time the form was greased. And in the end, what we offer with the platform again is this is something that you can also build with other systems, but it's the speed with which you can implement that, which is very interesting. And now the company is thinking about extending the solution, adding mobile devices where you can log additional data which you can't get from your machines. And this is the IT manager. So it's a Portuguese glass company with a plant in Spain. So this was a huge success in terms of the economics. The second case I brought with me, and this is a very interesting case, is about connecting workers. So this is also an interesting thing that in the industry, basically the worker is not connected at all. So everybody has a smartphone at home, but nobody has a mobile device in the factory usually. And it's because building mobile applications is quite challenging actually, because it needs to run really reliable, but in a factory, having good Wi-Fi coverage is not that easy. I mean, you have a lot of metal, you have a lot of interference, you have a lot of machines. And it's very challenging to build reliable mobile apps, which is very important. From our experience, if the worker is trying to use a mobile application and it doesn't work from time to time, or it's very slow if you click a button, this decreases tremendously the acceptance of the workers. And because the people are used from home how well things work, and if they don't have the same experience in the factory, then they don't use these systems. And what SKF, it's a Swedish manufacturer, is one of the world's largest manufacturer of bearing components. They produce bearings which are very large, like 2 or 3 meters, but also smaller ones, which are automated or produced in a very automated way. And there, it's an interesting thing because SKF is already investing a lot of money in digitizing their machines. So they're investing a lot of money in collecting data from the machines and making the data available in the cloud. And what they realized is that the person who then in the end can react to machine problems, to interruptions, to performance decreases, doesn't have the information on it. Yeah, you might have the information from anywhere in the world, but the person who stands like 50 meters away doesn't have the information. And what a partner of us has been implementing now for SKF is an application which makes the data available for the worker on a tablet and a smartphone device. And you can see it on the next screen. It's a very simple application if you think about the functionality, but it's a very powerful one that the worker has access to real-time data on the performance. So one of the most important things for the manufacturers is a KPI called OEE, overall equipment effectiveness, which is basically a sort of a approach of productivity of a machine. And so the worker can see the productivity of each of the machine modules, and he's informed if the machine has a problem, then he can add more information, he can create tasks, so that he knows when to do what, and he can also coordinate with his peers, of course. And this is an important factor because now the worker can react a lot faster if the machine breaks, this usually is recognized quite quickly, but performance decreases, for example, are not really realized or recognized during the shift. Only at the end of the shift, the people realize, we are slower than we should have been, because you don't have any real-time information on the performance of your machines. And again here, so this is Thomas from a company called NordCloud, who have been implementing the solution. They were very happy because, again, the speed with which you could deliver the mobile application is quite high. And by using our platform with the decentralized architecture, you don't have to worry about losing connectivity of your mobile device because you have your data locally, you have the application locally, and even if you don't have Wi-Fi connectivity, you can still access the last information that was synchronized to your phone. You can still create a task, you can still complete a task, and these sort of things. And once you reestablish connectivity, the information is automatically distributed by our platform, which just makes it very, very nice for a developer to build such a solution. So this is case 2. Case 3 is basically just an extension of the first 2 cases, where you connect the workers, you connect the machines, and you connect your business processes. This is a very important factor to integrate into ERP systems. So Klöckner is the company for which we have built this solution. It's one of the European largest distributors of metal components, and they also have an area where they are processing metal components. So somebody can order a steel profile, for example, and he can also tell the Klöckner, please cut the profile in an appropriate way, or I don't know, like cut the holes in the profile, whatever you want. And the challenge Klöckner has, and this is actually a very, very typical problem almost all the factories in the world have, they don't really understand how much did it cost to produce my product. So if you look at a specific profile, they don't really know, did I make money or did I lose money on this specific thing I'm selling to my customer? In the end of the year or in the end of the month, they know it, they know the bottom line, but they don't really understand what are the products that are profitable and which are not profitable. And it's because they don't have any access to data. They don't know for each order, production order, how long was the machine running, how long was the worker working, what was the exact amount of quality defects, and these sort of things. And in the end, the solution that was built is, again, an integration into different machines. In this case, it's laser machines, and a tablet application where workers can log data. They can start and stop orders. They can report material quantities. And they also have feedback via dashboards directly to the production machine. So it's also an interesting fact that just by providing dashboards, the people are working better. So this was also one of the predictions of the plant managers. He said to us, only by showing the people a dashboard and giving them feedback on where they stand according to their plan, they will work 5 to 10% faster, which is quite interesting. And in the end, it turned out they actually, once you have installed it, they were working actually quite a bit better. It's just because you have better feedback on where you stand in terms of your goals. And then this is an important factor, integration into the SAP system to extract order information. And then, and this is maybe interesting, an application to export the data to the cloud. Because, so for example, for Klöckner, they have several production sites in Europe, and there the cloud is really useful to basically centralize all the data across all the sites. So, and here we send it to Microsoft Azure, where you just send it to an SQL database, and then you have Microsoft Power BI to build your business intelligence reports to make use of the data. And the system is now planned to be rolled out to several sites, and then the cloud-based approach in terms of analyzing the data makes even more sense. But even if you don't have connectivity to internet, you still acquire the data from your machines. You're still able to log the data from your tablets. And this is an example. So on the left, this is nothing which we basically created. It's just Microsoft Power BI and making use of the data where you can see, maybe, I'm not sure if you can see this, the first sort of bar where you have like the interruptions. You can see what the machine was doing. Was it on? Was it interrupted? Was it producing? And then below, and this is important, the second information coming from the worker. Was he setting up the machine? Was he producing? And then you can compare the two information. Productivity increased quite immediately, interestingly, and Klöckner is expecting quite a significant productivity increase because they're now able to better plan their orders. Yeah, you can fill the capacity of your machines quite a lot better because you now really understand how long it will take or it should take to produce something. And this will, the more data you collect, the better your planning will become. So the first three cases are more on the left side, if you remember, like creating transparency, all the arrows up, and then basically driving human or by having human-based decision making. The second thing is, and this is now where it becomes even more interesting, in my opinion, is if you use software to basically control a process. And as an example of an automotive tier 1 supplier, which is producing components for diesel engines. So these are two assembly lines where you automatically assemble a product. They're spatially very close together, and in between the two machines, you have a worker picking one piece and putting in the next line. And here the challenge is that, first of all, you have to have traceability, of course, for automotive. So if BMW calls you, they need to know that you produced the product in the right way. And you want to basically have a very, very good prediction about your quality. Because again, if BMW calls you and the product is faulty because you have misproduced something, then it's really, really expensive. So here you have to have a very reliable system for analyzing quality. And this is a system which was built by one of our partners, where you have applications integrating into the machine. Yeah, you extract the machine data, the sensor data. In this case, it's a torque because you have the assembly, like what's the torque of your screws. You want to understand what's the product, the serial number, which you get out of the QR code. And then at the end of the second line, you analyze the data and compare it to the tolerances and decide whether the quality is good or bad. And if it's bad, then you automatically send a signal to the PLC to eject the product. And then you have a rework station where people can pick the product, can scan it, have a tablet computer to basically see what has happened to the product, and do I need to readjust? Can I repair it in some way? And this is also not a very difficult solution in terms of the functionality, but it's extremely, extremely powerful. And just to give you an idea, this is a system which was replacing a centralized system. Before that, they have a header database in the local data center, and sometimes you were not able to connect to the centralized server. And this machine is producing one piece every 20 seconds, and one piece costs around 350 euros. So you lose more than 1,000 euro per minute if you can't connect to the server. And even if you lose connectivity for a few minutes per month, which happened quite more frequent than that, then you lose a lot of money as a company. And in a decentralized approach, because you just have local decision making, it's just like the probability of the system failing is quite a lot lower, and you don't have to invest the same resources as a developer to basically build the same reliability than with a centralized system. Well, two more examples just to round this up. This is about intralogistics. This is also interesting. Often people are very much focused on machines themselves, like really optimizing machines and improving and building transparency on the machine. But you often forget that sometimes the machine cannot operate because you don't have the material at your workstation or at the machine, and you can start producing. And this happens quite often, actually. And people are running to the warehouse, to the storage location, and basically pick material from there. And this is an example built by an IT manager of an SME company in Stuttgart called CTA. They are producing, or they basically what they do is they fill in chemical technical products like glue or these sort of things. And they are moving a lot of material through the factory because the tubes are very small and you produce them in large quantities. And here the IT manager has developed a solution where you have an application where people can log or request material from a tablet computer at the workstation, and then you have an application on your forklift where the person or the forklift driver can basically see the information, what kind of material is needed. He can accept material, or can accept the transport order, and then basically deliver the material. And what's interesting is that there was already a system in place where people could log material quantities on tablets, and you use the same information to predict or to calculate when a pallet, for example, was ready, and to create the transport order. And this was implemented in 2 weeks by the IT manager without having a lot of programming experience, which just shows that how quickly you can basically build solutions using our platform. And the last one is basically the same thing, but just instead of informing a forklift driver, you have an autonomous transport vehicle, and basically the autonomous transport vehicle, the AGV, is deciding whether to pick up the material, and then you have the workers at the workstation who can accept or can confirm that the material was delivered. And this was a proof of concept solution which is installed in the Arena 2036 in Stuttgart by a company which is called Bayer Automation, which is a very innovative manufacturer of AGV solutions. Yeah, that's basically it from my side. I hope you got some ideas on what's possible. In fact, happy to answer any questions if there are any. And yeah, thanks for your attention.
Thank you, Max. I think that was very good, actually. I think it was a very good idea, or good overview of what you do. Any questions at all from the room? There's nothing in the chat.
I have a question. Are there any what's the hardware requirements to run the OS system?
Did you hear that, Max?
So you can run our software very easily on a Raspberry Pi. Like if you have 1 GB of RAM and a Raspberry Pi, it runs quite easily. I think the lowest powered device was a PLC from a company called Weidmüller, which had, I think, 500 megabytes of RAM and 600 megahertz. So it's not really demanding. And in terms of storage, you need, if you have a few gigabytes of storage, it's quite suitable for many, many use cases.
Yeah.
How are you able to manage employee integration and also achieving the low latency?
Excuse me, sorry, I was not really hard to understand.
end-to-end integration as well as low latency. Because I see on the previous slide you said that you have end-to-end communication and also you are achieving the low latency. It's not too low, but then still I want to ask how is it both possible at a time?
Sorry, it's not possible. Maybe Elsa, can you repeat?
Yeah. It might help. I think the microphone's here somewhere on the wrong side.
Yeah.
Question. How is end-to-end integration possible with low latency?
Sorry, I still can't understand it. I'm really sorry about that. Maybe Elsa, can you repeat?
Okay. Sorry, you'll come here and we'll try again. Sorry.
Okay.
Yeah. So just slow and clear, and it'll work.
Yeah. Are you able to hear me?
Now I can hear you better. Yeah.
Yeah. So how are you able to achieve end-to-end integration as well as low latency? Because you said both at a time. So what is the basis of the network that you follow?
So what we use is just LAN and Wi-Fi as a connectivity between the devices. And in terms of the latency, it of course depends a little bit on your network, of course, and on the applications. But latencies as low as 20 milliseconds is quite possible. And then it goes up. I mean, it depends on again on your network and how much data you send around. But what we don't do is because sometimes people try to understand what we are doing or how we are different in terms of automation technology. Things like Siemens is offering automation technology, where you basically have a predictable time frame where you like milliseconds, like 1, 2, 3 milliseconds, or even sub-milliseconds latencies. But this is not something that we do. So there's not deterministic real time, but it's fast as fast as your network basically allows it to do.
So it's completely dependent on the network. So if you have low bandwidth, then you can't for this. The product would not be functioning as good, right?
Well, I mean, it depends. I mean, in the example of the mobile devices, like even if you don't, our platform is very suitable for low or Wi-Fi coverage, for example, because you have all the data locally and you can take decisions locally, and then you just get rid of the data once you have suitable connectivity. But yeah, I mean, it depends on the use case. If you have a robot talking to a machine and your network is not good, then the use case won't work. Yeah.
Thank you.
Okay.
There's a question in the chat by Vincent. So we provide different runtimes, and we also provide a Docker runtime. So you can basically install ActiveOS as a Docker container on devices, and then you can have applications which are again Docker devices running in Docker, and you can deploy them inside of ActiveOS basically. And apart from the Docker runtime, we're also offering a WebView runtime applications for mobile devices, for Android applications. And we're currently working on a native Windows runtime so that you don't need Docker to run your applications.
Okay. Yep, and there's one question here. You might talk a bit loudly, that's okay.
Now it's fine. So you mentioned an example where the communication with the cloud was not reliable, was not quick enough. And
yes.
I wanted to ask, what was the specific factor in this reliability of the connection to the cloud? Was it the connectivity itself with the Wi-Fi protocol, or was it the response time of the cloud itself in the application?
I think that's a very good question. So I think in general, I mean, you can build a lot of use cases in the cloud. It's just like you have so many components that can fail until you reach the cloud and go back. That the availability is just a lot lower than you have if you have like a application running on your mobile device. And so one factor is definitely, for example, for mobile devices, the Wi-Fi coverage in the network, in the factory itself, which is difficult. But there's many different factors which can lead to low latency or not availability of your system in the internet. So they're different. I mean, there's many things that can fail, right? And can go wrong. And I think if you think about use cases where you scan a material and your workstation or your machine is automatically set up from this information, or a worker is loading a machine program on your machine directly standing next to him, or a robot being synchronized with the conveyor belt, these are sort of applications where if you have the availability of the cloud, you just limited by it, and it can happen that you don't have connectivity. So I mean, we have built cloud applications at the beginning, actually, when we started ActX, because we thought, okay, the cloud is a good solution, but then we realized it doesn't work for mission critical, or not as well for mission critical solutions.
Okay, happy with the answer, or?
Yeah,
happy?
Another question.
Yeah, please.
The system of traditional cloud, because if you don't use the cloud, then you need solutions for typical cloud applications like predictive maintenance, like any analytics tasks. So is your system dimension to hold also these kinds of algorithm solutions, or would you say that these kinds of applications deserve to be hosted on the cloud?
Yeah, I mean, if you have very power hungry and data intensive applications, like maybe like predictive maintenance. I mean, I was just last week talking with a company called Jungle, which are doing basically, they predict the behavior of your system, and there probably it makes a lot of sense to do it in the cloud. If you don't, if nothing happens, if you don't have connectivity for a few minutes, then it's very, very well suited to do in the cloud, and it also makes more sense than basically bringing very power intensive and expensive computers maybe to your on-premise or in the factory itself. And we see ourselves more in, I mean, you can also run algorithms, of course, on the edge for predictive maintenance. It depends a little bit on the use case. But for us, it's more about orchestration between devices. Like when you, like the result of the predictive maintenance is the prediction that the machine will fail. And then this communication to the worker, to other people in other departments, these are sort of more the process automation use cases that we have in mind, and where our technology is more suitable. And it's complementary. Some run in the cloud. The predictive maintenance cases might run all in the cloud, or some of them at least. And we have other use cases where it's more about automating and controlling the process. If this makes sense, I'm not sure if that answered your question, but
yeah, I like the answer too. I like the answer. Yeah, Tom.
I would have the question, Max, if you could probably tell a bit about your perception of the movement from the cloud towards the edge, and how you would see the pros and cons of your completely decentralized architecture towards an architecture where some functionalities are already moved from the cloud to an edge architecture, but still need a central node to basically connect machines.
Yeah, I mean, that's what I was trying to, maybe you can show this again. So there are things that the things that we see that move to the cloud, it's a lot of pre-processing or running some algorithms on the edge. But if you and if you have a use case, like again, like the robot talking to the machine, and you have the centralized component, this architecture, in our opinion, is not very suitable to do that. But in our system, if you want to centralize data again, then of course the cloud makes a lot of sense to use as a system. That's why we also send the data to the cloud again. It depends on what you want to build, I think. If you, as soon as you need two computers reliably speak to each other, you are much better off if the computers talk directly to each other instead of like central component. And we don't see, honestly, all these things moving to the edge in terms of the industry. It's not about process automation. Like, I have never really seen these use cases. It's more about single devices, a machine where you pre-process information, where you capture a lot of data, and you don't want to send everything to a centralized node. But that two edge devices talk to each other, like these sort of use cases are very rare, at least from what we have seen so far in the industry. And I think you need to have both to really cover and build the digital factory. So you can't build everything with a decentralized system, especially if you have a lot of data that you want to analyze and make predictions and these sort of things. But you can also not do everything if you just have a centralized system in the cloud, or centralized systems in general, in my opinion. And so does it answer your question, or?
Yeah, partially, but I was not mentioning. So I was wondering if you have a gateway on the edge, right, that takes that takes away some of the problems that comes with latency and connectivity towards the cloud. I was wondering how your completely decentralized solution would compare to such a solution where the machines are not connected to each other, but just to a gateway basically that is running on the edge. So this is
then it might make sense to just use the cloud-based system on the edge. So if you just have one machine and one gateway where you want to not send all the data from the machine in the cloud, there's no real reason to use or there's like not a benefit to, or no benefit in using our technology, because what we do is we connect two computers. And if you just have one computer which sends data somewhere up, where with not a lot of requirements in terms of when it arrives there, because you don't get feedback back and control something, then you're well off with the edge solutions which are focused on a single device. So if it's just about a single computer, then I think both it's a good option to use these cloud systems which run on the edge.
Okay.
Does it answer? Is it?
Yeah, I think that makes it more and more clear. Yeah. Thanks.
Yeah.
Last one, maybe.
There's one question in chat. I'm just seeing that about 5G.
Sorry, I saw that. I forgot. God, please.
I'm actually not 100% sure if I understand the question about considering 5G integration to have a wider ranges. I mean, in general, 5G is a trend to more decentralization, and in terms of how it compares to us, I think it helps us because I mean you have there's a possibility to get rid of cables, which basically helps us, and you don't have to set up a lot of cables and can use maybe 5G. It might be challenging still to use 5G in the factory because of all the metal, and it's even more difficult with 5G to have a good coverage, I think, in this environment. But definitely it helps us. And instead of you having a cable where you have low latency requirements, you can just use 5G for that. Not sure if that answered the question actually, but
don't complain. I might suggest that they might be happy.
Yeah. Okay.
Yes. Yeah. So one last question from the floor.
No, it's really interesting platform there. But my question would be, how do you handle deployment and updates of applications? Because you have any components here, and
that's a very good question. So ActiveOS is a program running on a computer, and getting and deploying an ActiveOS or updates of ActiveOS, for that we just use device management software. So for example, for tablets we use AirWatch. For gateways we use software called Balena. There's a lot of different device management software on the market which you can use to install and deinstall basically software on a device. And we offer tooling though. Once you have installed ActiveOS, we offer tooling to configure ActiveOS to install and deploy an app inside of Actix. But for that you need to have ActiveOS running and you need to have access in the local network. We are currently working also on a cloud-based application to access all the devices from the cloud. But today is that you have to have access in the local network. So we allow you to configure and change settings and these sort of things. But the deployment of ActiveOS itself, for that you would use a third-party software.
Thank you. Okay. So I might end it there, if you don't mind, just to keep things to time, even though we're off, it's over already. Just a really big thanks to Max and Markus for their time. I know it's quite late, I know they have other things to do, but really thank you. It's great to have two external guys who want to come and talk here. I'll probably just close by saying, if you would like to talk yourself here, and I know these two guys, it might seem intimidating, you know, they are quite well known in Munich in the IT field. If you're just a normal developer, or even something to do with IoT, and you have some ideas, opinions, I would always encourage you to come and share. And if you would like to know what Concept Replay does, and maybe are looking for a job in the current climate, it could be happening, come and talk to me and I can connect you to the right people. Okay, so Markus and Max, thanks again. I'll put it in the call,
sir.
And we'll talk soon, I hope.
Yeah,
Thank you. Bye.
Thank you. Bye-bye.